What up, people? It's your boy again, Mr. Noland. Today we are going to be talking about prime factorization. Now, what do y'all think that means? I'll give you a clue. We're going to deal with prime numbers. Back from elementary, does anyone remember what a prime number is? A prime number is a number that can only be multiplied by 1 and itself. So here we go. A prime number is a whole number that has exactly 2 factors, 1 and itself. A composite number is a number greater than 1 with more than 2 factors. Both 1 and 0 are neither prime nor composite. And finally, prime factorization is when a composite number is written as a product of prime numbers. You're going to be like, wow, Mr. Nolan, that makes no sense. Guys, this is actually going to become very, very easy. Just give us a... Let me go through some of these notes. Now, examples. Prime means there's 2 factors only. So a prime number could be 2. What multiplies to give you 1, or what multiplies to give you 2? Well, 1 times 2. Those are your only 2 factors. What's another prime number? Well, 3. The only things that can multiply to give you 3 would be 1 and 3. What's the next prime number? Some are going to say 4, Mr. Nolan. 4 is a prime number. Well, no, it's not. Because guess what? 1 times 4 is 4, but what about 2 times 2? It's got more than 2 factors, so that is a composite number. Your next prime number would be 5. The only thing that can multiply to give you 5 would be 1 and 5. Next one, 7. The only thing that multiplies to give you 7 would be 1 and 7. The next one, you're like, 9, Mr. Nolan, 9. Wrong. Remember, you got 1 times 9. You also have 3 times 3. So that is a composite number. It's got more than 2 factors. The next one you're going to have is actually 11. That can only be 1 times 11. Then I'm just going to go ahead and finish filling this out. You have 13. You have 17. And you have 19. Now, are there more prime numbers? Absolutely. We're just stopping right there. This is going to go on for forever and ever. Alright, now let's get to it. We need to make a factor tree. It is called that because it puts down roots. Okay, so here's the number. We're going to turn this into prime factorization. Okay, so now, what multiplies to give you 40? Some of y'all are going to be like, 4 times 10. Some of y'all are going to be like, 2 times 20. Some of you are going to say 8 times 5. There's a lot of numbers that multiply to give you 40, right? It doesn't matter which numbers you use to multiply to give you 40, which whole numbers you use to multiply to give you 40, you will get the same exact answer. In this case, let's use 4 times 10. Well, you're going to have to break down our numbers until we get to prime numbers. Is 4 a prime number? No, it is not. What multiplies to give you 4? 2 and 2. Are 2 prime numbers? Yes. So I'm going to circle my prime numbers. What multiplies to give you 10? Well, 2 times 5. Well, you just told me 2 is a prime number. Is 5 a prime number? Well, yes it is. Well, notice what I did. I circled all my prime numbers because I know that's as low as they can go. It makes it easy. Okay. Well, right here, when all the numbers are prime, you are finished factoring. Now write out our factors in factor form. Well, we have a 2 times a 2 times a 2 times a 5. Now write it in exponential form. Well, how many 2's do you have? How many base 2's do you have? Well, my base here is 2, and I have 3 of them. But Mr. Nolan, I also have a 5. Well, that is correct. So we're going to have to take 2 to the power of 3, going back to our exponents notes, and we're going to have to multiply that by 5. And how many 5's do you have? Well, I got 1. Some are going to be like, put a 1 up here. No. Guys, if you see the number 5 right here, or the number just like this all by itself, it's assumed that the exponent is a 1. You don't have to rewrite it. Now, some of you are saying, Mr. Noland, I use different numbers. I want you to prove to me that you get the same exact answer. Okay, so I'll do that. So let's say you used 8 times 5. Okay. Well, 5 is a prime number, so I'm going to circle it. What multiplies to give you 8? Well, 2 times 4. Well, 2 is a prime number. 4 can be broken down to 2 times 2, right? Oh, would you look at that? 2 times 2 times 2 times 5. Oh, 2 times 2 times 2 times 5. Wow, I'm a genius. All right, let's try one more. Some of y'all said I used 20 and 2, Mr. Noland. All right, well, let's check it out. 2 is prime number. What multiplies to give you 20? Some of you are going to say 4 times 5. Some of you are going to say 2 times 10. I'll go with 2 times 10. You'll get the same answer again. And then what multiplies to give you 10? 2 times 5. Oh, would you look at that? You get the same exact answer. So it doesn't matter what factor you use on the first one. You'll get the same answer at the end. All right. Now it says, let's work backwards. We are given the prime factorization. Now we must find the simplest form. Well, notice how it says 3 squared. So that means we should have 2 3's, which I do. Then it says 5 squared. So I should have 2 5's, which I do. Now let's go ahead and break this up simply. Some of you are really going to do 3 times 3 and 9. 9 times 5 is 45, and then 45 times 5. You may do that if you want, but I'm going to make it simple here. Let's break it up. What is 3 times 3? Well, that's 9, Mr. Noland. Well, that's good. And I want to multiply that by, well, what's 5 times 5, guys? That's 25, Mr. Noland. Very good. Now it's just 9 times 25. Does anyone know what that is? 9 times 25? Let's multiply. 9 times 5 is 45. 9 times 2 is 18. Plus 4 is 22. So there's your answer in standard/simplest form. Right there. All right. Well, guess what, guys? It says practice problems. So I'm actually going to stop this video and let you try this on your own. All right? All right, guys. I hope this video helps. Have a great day. Bye.